Hey everyone! Have you ever stopped to think about how we actually talk to computers? I mean, these things are just a bunch of zeros and ones, right? So how do they run our favorite games or even the operating system you're using right now? Well, it all comes down to having a conversation. And today, we're going to learn the language for one of the most powerful conversations you can have with a computer, C++. So, here's our game plan. First, we'll ask, why do we even need programming languages in the first place? Then we'll get right into what C++ is. After that, we'll check out its superpowers, figure out what this whole thinking with objects thing is all about, and finally, see how code actually becomes reality. Let's dive in.
All right, let's kick things off at the very beginning. It's all about that conversation between us and our machines. Before we can get into the specifics of C++, we have to understand the fundamental problem it's trying to solve.
I mean, really think about it for a second. How do you actually get a computer to do what you want? You can't just, talk to it and say, hey, create the next blockbuster video game for me. It just doesn't work like that. There's this huge communication gap we have to bridge.
And here is that gap. At its very core, the only thing a computer truly understands is machine language. We're talking just zeros and ones. That's it. Can you imagine trying to write a complex app, like a web browser, using only zeros and ones? It would be an absolute nightmare for our human brains, just impossibly tedious.
And that's exactly where programming languages come in to save the day. They're basically the ultimate translator. Think of them as this incredible bridge that lets us write instructions in a way that makes logical sense to us, and then that bridge translates it all down into the zeros and ones the computer needs.
Okay, so we've established we need a translator, a language. But there are tons of them out there, right? Today, we're focusing on a real heavy hitter. So let's get to the main event. What exactly is C++? So the official definition calls it a high-level general-purpose programming language. Whoa, okay, let's break that down. High level just means it's closer to our human language, making it way easier to read and write. General purpose means it's like a Swiss Army knife. You can build pretty much anything with it. And the most important part? It's an extension of an older language called C, which was already a really big deal.
And yeah, C++ has been around for a while. It's definitely not the new kid on the block. We're talking development starting way back in 1979 by Bjarne Stroustrup. The first commercial version came out in '85. Now, what does that long history get you? It means the language is super mature, it's stable as a rock, and there's a gigantic community of people out there who use it.
Okay, if there's one thing you take away from this whole section, let it be this simple equation. C++ equals C plus OOP. This is the absolute heart of it. The creator basically took all the awesome stuff from C, its incredible speed and raw power, and bolted on this game-changing new way of thinking called object-oriented programming, OOP for short. And you can really see the difference when you put them head-to-head. The original C was what we call procedural. Just think of it like a simple recipe. You follow the steps from top to bottom. But C++, with its object-oriented paradigm, is a completely different mindset. This new approach brought in powerful ideas like classes and made everything way more secure. It was a total game changer for building massive, complicated programs.
All right, so we know C++ is C with some extra goodies. But what are those goodies? What are its superpowers that make it so fast and powerful? Let's find out.
Well, for starters, there's that whole object-oriented thing, which is amazing for modeling real-world problems in your code. But the big one is speed. C++ is fast, like really fast. Why? Because it's a compiled language. That means when you're done writing, a special program chews through all of your code and spits out pure machine language all at once. There's no translating on the fly, which gives it a massive performance boost.
Okay, I've said object-oriented programming, or OOP, a bunch of times now. It really is the soul of C++. And I know it can sound super technical and intimidating, but trust me, the basic idea behind it is something we all understand intuitively. So it all begins with something called a class. Now, a class is not the actual thing. It's the blueprint, the recipe. Let's use the car analogy. The car class would be the design document. It says, okay, every car we build is going to have 4 wheels, an engine, and a color, and it needs to be able to do things like speed up and slow down.
And if the class is the blueprint, then an object is the real car that rolls off the assembly line. That shiny red BMW over there, that's an object. My neighbor's silver Audi, that's another object. They both come from the same car blueprint, the same class, but they're unique, individual things. And that, right there, is the magic of OOP.
But it gets even cooler.
Using this blueprint idea, you can do something called inheritance. Imagine you want to design an electric car. Well, you don't have to start over. You just create a new electric car blueprint that inherits everything from the regular car blueprint, and then you just add the new stuff, like a big battery. See? You're building on what you already have. It's incredibly efficient.
Okay, enough theory. We've talked about why we need languages and what makes C++ so special. Now for the fun part. Let's see what this stuff actually looks like when code becomes a real running program. Just one quick reminder of that crucial step we talked about. We write our human-readable C++ code, we call that source code. Then we hand it over to our translator, the compiler. The compiler does all the heavy lifting, converting our C++ into the zeros and ones the machine can actually understand.
And here it is, the moment every programmer remembers, the traditional Hello World program. I know, it probably looks like a bunch of gibberish if you've never seen it before, but don't worry, every little piece of this has a job to do, and we're gonna walk through it right now.
Okay, let's dissect this thing. That first line, #include IOStream, is basically you saying, hey computer, I'm gonna need to print stuff to the screen, so please grab the library that knows how to do that. Simple. Then you've got main function. This is the starting line. It's the very first place the computer looks to begin running your program. Inside, we have count. That's our command to actually print something out. And finally, return 0 is just our program's way of saying, I'm finished and everything worked out great. That's it.
And believe it or not, you've just understood the fundamental structure of a C++ program. Seriously, that basic pattern, including some libraries, having a main function to kick things off, and putting your commands inside, that's the foundation for pretty much every C++ application out there.
So, what can you actually build on that foundation? Well, you're literally using C++ right now. The operating system you're on, whether it's Windows or Mac OS, C++. Your web browser, like Chrome or Firefox, C++. Those incredible high-performance video games you love, you guessed it, C++. It's the engine behind so many things we use every single day.
So when you really get down to it, C++ isn't just a bunch of commands and symbols. It's a tool, a really powerful tool for building the fast, complex, and super reliable systems that our entire digital world runs on. It's a language that literally builds worlds. So the only question left is, what world are you going to build? Thanks for joining me on this one.